Welcome to 3 Inquisitive Kids. In this video, we will be solving a problem about quadratic functions. We're going to try to find the extrema of the function f of x is equal to x squared minus 2ax plus 1 on the interval from 2 to 4. Let's observe our function. We see that the coefficient of the x squared term is positive. This means that we have a parabola that's opening up. We also know how to find the x-coordinate of the vertex. The x-coordinate of the vertex is always equal to negative b over 2a. In this case, a is equal to 1, b is equal to negative 2a, and 1 is c. Now, when we substitute in our values for b and a, we see that x is equal to 2a over 2. Also, right now, this a and this a are two different a's. This a is the one we're actually using in our current function. This means that when x is equal to a, we are at its vertex. We're at the vertex of the f of x. It also means that the parabola is symmetrical about the line x is equal to a. Now, in order to answer the question, we have to split into multiple cases. The first case is if a is greater or equal to 4. The second case is when a is between 2 and 4. These are the two values on either end of our interval. And the third case is if a is less than or equal to 2. So let's start with our first case. If a is greater or equal to 4, here's x is equal to 4, and here's x is equal to 2. This is the interval we're dealing with. It means we're only focusing on a decreasing part of the parabola. So in this case, the maximum value would be f of 2, and the minimum value on the interval would be equal to f of 4. Now what would happen if a was less or equal to 2? It means that our interval would lie on this side of the parabola. This line is x is equal to 2, and this line is x is equal to 4. As you can see, we're focusing on the increasing part of the parabola. In this case, the maximum value would be equal to f of 4 on the interval, and the minimum value on this interval would be equal to f of 2. And now, what about our next case? A is between 2 and 4. It means x is equal to 2 is here somewhere, and then x is equal to 4 is here somewhere. This case is slightly more complicated, so we have to split into even smaller cases. The first case, we'll call it case A, is if A is between 2 and 3. And case B is when A is between 3 and 4. Now, why are we saying this? Well, 3 is a number right between 2 and 4. If A is greater than 2 but less than 3, x is equal to 2 is here, x is equal to 4 is here. And this middle part is in this middle line is x is equal to 3. In this case, the minimum value would just be at the vertex. It's actually true for both of these cases. All we have to focus on is the maximum value. On this interval, the maximum value would lie where f of x is equal to f of 4. So the max is f of 4. And the opposite is true for case B. Now we already have the max and minimum values laid out for each case. All we have to do is simplify. So let's substitute 2 into our function. We have 4 minus 4a plus 1. This is equal to 5 minus 4a. And f of 2 is always going to be equal to 5 minus 4a. And now what about f of 4? f of 4 is equal to 16 minus 8x plus 1. This is equal to 17 minus 8a. And what would the vertex be? We just substitute a into our function. That would give us a squared minus 2a squared, which is equal to negative a squared plus 1. And there we have it. We have found the extremum values, the maximum and minimum values of f of x on the interval from 2 to 4 in all of the possible cases.